All right, so I got kind of another unique press brake project today. So I got is this piece of sheet metal I need to reproduce. This is for a guy who's restoring an old Pontiac. This is like an inner quarter panel support brace deal. Goes under like the quarter window glass. And obviously it's pretty rusty, and they want to just replace it instead of trying to repair this. So what I need to do is make a die to be able to get these two bins this close together. So it needs to be a very narrow bottom die. And the tooling I have currently is too wide. So what my plan is I'm going to take this piece of basically take 3 pieces of metal, and bolt them together, and have these outer pieces raised up a 1/4 inch. So it'll be something like that. And then that 1/2 inch material by itself will slide down into my, I don't know what you call that, the tooling holder or whatever. You can see the tooling in my press brake uses a 1/2 inch wide, like the old American Standard style tooling. So that piece of flat bar will slide in, and then the 2 thinner pieces on the outside will bear down on this, because these are what's designed to kind of take the pressure. And then this whole thing is only 3/4 of an inch wide overall, and the spacing from the outside to the center will work to get these 2 bins close together like that. I'm gonna modify the part a little bit. I don't have the ability to do this kind of fade to nothing deal in this bend. So these 2 bins in the center are just going to continue all the way out. The way they weld into the car doesn't really make a difference. And this is a piece that literally will never be seen again once it's put into the car. And so the owner's not super picky. Basically this width though, I guess you'd call it the height of the part, the total height, has got to stay very close to what it is, because that quarter glass rolls down and it goes down alongside it. So I've got to be semi-precise, but it should be pretty easy. And then I'm basically going to make this part extra long, and then they're going to cut and trim the ends to fit the car. So it's kind of a cool project. I enjoy these kind of weird challenges like this. So I'm going to get this, I'm going to bolt these 3 pieces together. I'm going to put a bunch of bolts down the length. That way I don't get any distortion from welding. And the way this part sits in the machine, I can't put welds here. And if I put welds on the inside, that would interfere with the sheet metal being bent as well. So I'm going to do a bunch of 1/4 inch grade 8 bolts, probably like every 3 or 4 inches. You know, this is thin material. It's 20 gauge. It's not going to take very much tonnage. And this is kind of a one-time use die. So I'm not going to spend a lot of time on it. It just needs to work. Doesn't need to be pretty, doesn't need to last forever. It's basically going to make, what, 1, 2, 3, 4, 5, 6, 7, 8, 16 bins. That's all it needs to survive for. So I'm going to get the holes laid out and drilled, and then I'll bring back the video once I've basically got it assembled. Okay, I thought I'd share a couple tricks while I'm laying this out. And catch the light right, you can see I use a scribe whenever I'm trying to do something that needs to be precise. So this is a cool little tool I picked up. I found it on eBay, and I had the best luck searching by, it's called a scribing caliper. It does have kind of like a vernier style scale on it. I usually don't use that. It's hard for me to see. I've got terrible eyes. But I usually will set this gap with a set of regular calipers. But it's cool. It's got this little roller and then this little scribe. And so whatever you want your dimension to be, you set it, and then you can just set it on the edge. It takes a little practice. You need to hold this semi level and squared your material, but then you can just run it down the length and get a nice consistent parallel line. And it's got some adjustments for the depth and whatever, and you know, the little scribe piece is it's got to be sharpened every once in a while. It's a pretty cool little tool. You know, I love to build stuff, but I hate to measure. So I like to use a lot of I don't know what you call it, like physical measurements. Even if you're just a welder, you know, I hate to say the word just a welder, that's stupid, but you know, these, you know, are typically used by machinists. But I use these so much. So I use these, in this case, I just would come up to the scribe line, do my next scribe, my next scribe, my next scribe. Again, the spacing doesn't have to be that accurate, but to me it's cool because this is exactly 1 inch by 2 inches by 3 inches. All the angles are pretty much perfect 90s. Pretty cool tools. So when you're building parts, you know, it just comes in handy as a spacer, a square, whatever, like super handy. I've got the big brother too, 246 block. So these are, it's called a 123 block. This is a 246 block. You know, if machinists saw how I use them, they would probably cringe. But yeah, I buy the cheapest ones I can find on eBay because I abuse them. You know, they get welding spatter on them, but the cool thing is they're relatively hard, and I think they're cast iron. So the weld spatter really doesn't stick to them anyway. It comes off really easily. So anyway, cool tool to have. I've also got assortment of these squares from Fireball Tool. You know, I don't really like to plug companies, but these are cool. Now I've got a couple different ones. I've got that big 12-inch. I got this little guy. Then I've got this one down here too. Pretty handy. I build a lot of stuff with square tubing that's got to be square, and these work pretty good. You can clamp your pieces all together. Anyway, off subject. So I just figured I'd show some tricks. And again, I like to use scribes because it's pretty easy. If you got a nice, good, sharp center punch, you can feel the grooves that scribe puts in and really get it right on the money. If you're doing something that's precision. Again, this doesn't really matter because I'm literally going to clamp the 3 pieces of metal together and run the bolts through, or run the drill bit through on the drill press. Anyway, so I'm going to get this center punched and drilled, and then I'll come back and I'll show the bending process when I get it all put together. Okay, so here it is, all drilled and bolted together. You can see on a bottom die, the opening does not need to be a V shape. You know, you can see like that guy is. Because for, 3-point bending, air bending, it's called, where the material is bent over air in the middle, I guess you would say. The shape of this opening doesn't really matter because it's just this point of contact, and then the upper punch. Some bending processes they call coining, where it does fully compress and bottom out. But that's not what we're doing. So you can see this center piece of 1/2 inch is just basically there to go into the die holder, and to hold the die straight up. And then what's actually weight bearing is going to be these thinner pieces, and they come down and rest on the tops here. You know, there's not a lot of contact here, but this is not going to see very much tonnage, again, because it's only 20 gauge that I'm bending. But that's it. Pretty simple. I'm going to use, you know, one of these dies for the top. The radius is maybe just a little big for what I'm doing, but again, for this part, it doesn't matter. So I'm gonna get this set up. I've got to do some pattern work for those pieces, get the blanks cut out, and then we'll get them bent. This was in the machine from the last job I did. There's another super quickie homemade die. I guess this would be the punch. But I bent some pieces. Well, I guess they're still here. I can show you. This bumper project I'm working on. I made these pieces here. So it's kind of hard to tell, but these have kind of a regular sharp bend right here. And then the rest of this was done every 1/4 of an inch. So I would, you know, I took some scrap and I experimented with the down stops on the press brake to get it to come down to where I want it to stop each time. And then I would bend it every 1/4 of an inch, or I would hit it every 1/4 of an inch. So this had like, you know, 8 or 10 different bends with that rounded upper punch to give me a nice smooth radius. So I threw that punch together for that job. When I go to my local steel supplier, they sell a lot of like remnants and kind of like scrap type stuff. And I got this guy there. I keep my eye out for usable things because it's pretty cheap. It's just sold by the pound, like scrap value basically. So I try to keep some 1/2 inch flat bar around, and then various pieces around material and different things to make my own dies. And again, like, this is a pretty narrow V for something this big, but I was doing a very broad, gentle roll. And so it wasn't, you know, coming in very deep. But hopefully this just shows that with, you know, a little bit of time and some scrap material, basically, it's really easy to make tooling. And again, this stuff is not, you know, production grade. You're not going to get thousands and thousands of bends out of this. But for little one-off jobs, it's going to do the trick just fine. So I'm going to get the pattern made up, and I'll bring you back when I'm doing the bending. Okay, so my way of doing the pattern on this, I need to figure out, you know, how long this piece is going to be when it's flat. This is the first time trying this idea, so we'll see how it works out. But I took masking tape and carefully made sure it was, you know, had no gaps or bubbles in it. I did that on both sides. Then I'm going to lay them out, and then I'm going to peel this one off and line them up. You know, I'm going to measure out carefully a center line mark, and then I'll lay the other one next to it, and then basically get an average. So I cut these carefully with a razor blade to the edge. And being that the tape is rolling around the outside of some bends and the inside of others, and then the opposite of the other side, I think if I do an average length between the two pieces of tape, that should give me a good overall size of the sheet metal. I also carefully marked where the bends are. I'm not sure if I'm going to use that with the tape, but I figured I'd just do it since it was there. I'll probably actually measure out you know, this distance on the inside between the bends, and then the same thing here. I'll measure these two channels out and just lay it out. Generally on things like this, I'll spend the time to just measure it all out really carefully and draw it in CAD to get all my bend lines figured out. But I'm going to try this first. I've got extra sheet metal, so if it doesn't work out, I'll resort to my old way of doing it. So I'm going to get this laid out and get some blanks cut out and see how it goes. So I'll bring it back after I get that done and start the bending. Okay, so I decided to do a quick practice bend and some scrap material the same thickness. First, I did one bend and then snuck up on the angle to try to get the angle the same. And try to see how I can show this. It's really, really close. Kind of hard to show, but you can see this is more or less touching and there's a little gap here. So my height between the two bends is just a hair too much. And that's kind of unfortunate. You know, the reason I chose to only use 1/8 inch was you would do the first bend and then you would take that material and slide it in until it basically bottomed against this. And by my first measurements, it looked like that was going to be perfect, but it's not quite right. So I think I'm going to have to take and hit the edge of this flat bar with a grinder and try to just knock a slight bevel all the way down it as even as possible so that material can slide in just a little farther on the second bend of that jog. Again, because see if I can show it. Because basically, I bent the lower bend. Can't really show this with one hand, but that bend first, and then turn the material over and slid it in until trying to hold this with my knees until the inside of this bend was resting on the corner of the flat bar right there, and then it did this bend. So it's off by just a little. The guy kept telling me that the level of precision is very it's very loose on this part. And I'm going to throw some calipers on it and get a better idea of how far it's really off. Another thing I could do, because again, I don't think it matters, is if I change the angle of this and basically lay that down a little, it'll bring the height down. But I'm going to throw some calipers on this and get a better idea of the height between the two bends and see how far off I really am. Just throwing this old bent, rusty piece against it, it's probably not the most accurate way to measure it. But the quality of the bend is actually really nice. You can see there's a slight marking of where the dies hit, but pretty minimal, and that's with a regular press brake dies. You're always going to get that to some extent, unless you have the they make like a protection film that you lay in here, or they actually make dies that are made out of I've seen urethane, and there's also like Delrin or some other material like that. But I'm not going to go through the effort of making a plastic die for something that is going to get used once. Shop dog sneaking things out of here. So I'm going to play with this a little more and see what I come up with. All right, so what I ended up doing is between the tape and those marks and just physically measuring the part all out with some calipers. I decided to lay it all out and draw it in the computer. For me, I don't have a sheet metal shear or so my plasma table is the best way I have of cutting a nice blank. I've already deleted all my kind of construction lines and stuff I use to figure this out, but I put these little outward nibs or little deals. So these are markers for where the bins are going to be. So I've got the 2 bins here close to the edge, which would be these 2 guys, and then the 4 bins in the middle for that center rib, 1, 2, 3, 4, and then the same thing on that end. So what I can do is use these so I don't have to set my backstops and try to measure them out. My backstops on my press brake are just totally mechanical. I set a speed square to my dimensions and use that off of the bed. And it's pretty accurate, but it's not real fun to do. Especially I would have to set it up 8 different times. And so I just put these little pointers where my bins are located. And then once I have it all formed up, I can just grind those off. These are they're 1/8 of an inch by 1/8 of an inch. So they're just enough to see and to line up under the top punch of the press brake. And then I can easily grind them off once it's done. And this was that die as I was figuring it out. I drew the part, the angle and everything in here, and then built the die off of that. And then I made a big label here of the materials and took a picture with my phone. So when I went to the steel yard, I had a list of what I needed. But anyway, I'm gonna go ahead and get this guy cut out, and then bent up, and hopefully this works out the first try. I use just a super cheap, basic 2-dimensional CAD program. It's called QCAD. I use that for everything I do on my, for any parts I draw, but on my plasma table. And then my plasma table is a Torchmate brand, and so it has its own software. And so I brought the parts in, and then do the tool pathing for the plasma. So here's a lead in, a lead out, and this thick heavy line is the kerf width of the machine. And so it sets this width based on your real life measurement of the kerf width for whatever material you're cutting. And so there's like a tool library and for each different material thickness and amperage, and you got to build up. But so my machine's got a 2 foot by 4 foot cut area. For me, this is the most convenient way. Is my X is the 24 inch and my Y is the 48 inch. So yeah, so I got them laid out, 0-0 corner. I'll go cut these out and then see how these bin lines work out. Hopefully, I've got enough material to do this a couple times if I'm off. But I was pretty careful in my measuring. And again, this part is got pretty big tolerances. So here we go, give it a try. I'll come back when I get these pieces all cut and I'll show you the actual bending. Okay, so here's the blank. You can see those little mark indicators. So basically all I do is slide it in and then line up one of those little points with the center of the top punch on both ends. And then I've already got the down travel stop set. Unfortunately, I'm gonna have to put the camera down for a minute while I get this lined up. I need both hands. Once I get that kind of pinched in place, I'll come back, but I I've already done the first one. And it turned out really good. It's really, really close to the original. Like I said before, we didn't do this kind of flare out stop. He wanted me just to continue it all the way out. And I made them long so he can trim them. Yeah, it turned out nice though. I'm pretty happy. Bends are nice and crisp. I've got to like kind of bend it over. I don't know, I may try to use the press brake. It's hard to see, but this has got a slight, the whole thing is slightly curved. So I might go through and hit a couple of the bends a little more to kind of give it that crown. It's real slight. I might even just kind of push it over the edge of the bench. But like I said, let me get this one clamped in place, and then I'll show the bending. All right, so I got it locked in place in position. Again, if you can see, I kind of use my fingernail and I can feel the edge of the die and that little nib. And then this machine, I got a 2-position pedal, one for up, one for down. So it's got the stop set. And then now what I do is I flip it over. And like I mentioned before, I ground the edge of this die. I wish I hadn't, because I went too far. Because the whole idea was to bend the first bend and then just push this till it stops. But I went ahead and I did the that little lineup point for that bend as well. So there's no sense in showing every step. Each bend is exactly the same. They're all the same angle. But that's it. Part came out pretty nice. You know, obviously this was made on some large stamping press 60 years ago. But with a little ingenuity, it could be copied. Well, hopefully this is helpful for somebody out there, or shows you what you can do with a homemade press brake. Yeah, that's it. So thanks for watching.